In section 6.8, and we're just going to talk about using coordinates. So just a reminder about our tools. We have some tools that we talked about the other day. Our tools are slope. Well, let me back up one thing. We need our points. We're going to use slope. And we talked about using slope to find out if sides are parallel, like we did on the opener. We're going to use the distance formula. We'll use the distance formula to decide if sides are the same length. And we'll use the midpoint formula to find midpoints or bisectors, something to do with the middle of segments. Same tools that we've had before. But what we're looking at today is our points are coordinates, or our points are variables, not necessarily a number for our coordinates. So let's look at some examples of just calculating some things when we have our points as variables. So let's say our points are PQ and RS. And we want to find, for the first example, find the slope between the points. Well, we're going to find the slope just like we've done before. I would label this x1, y1, x2, y2, and use our slope formula. The slope, y2 minus y1, s minus q, over x2 minus x1, r minus p. And unless we knew what s, p, q, and r were, this is all we can write. That's the slope. If we wanted to compare it to another slope and decide if the sides are parallel, the other slope would need to be exactly the same as that for them to be parallel. If we wanted to find the midpoint, we're going to find the midpoint, just like we did before. x2 plus x1, r plus p, divided by 2. That's my x coordinate. y2 plus y1, s plus q, divided by 2. That would be the midpoint between those 2 points. And we'd have to know more information in order to plug some numbers in there. If we wanted to find the distance, between the points. So those are at the vertices of a side of a polygon, something like that. And we want to find the length of the side. That's the distance between the points. Well, our distance, just plug those into the distance formula. Square root of x2 minus x1, r minus p squared, plus y2 minus y1, s minus q squared. And that's how we would write the distance between those 2 points. If we wanted to see if it was the same as some other distance, the other distance that we came up with would have to be exactly the same as this for them to be the same distance. Same length. All right. So this is part of what we're going to do today, is just calculating these things, plugging these variables into our formulas instead of plugging numbers in. Same process, we just use a variable instead of a number. The other thing that we're going to do today is find missing coordinates. So let's take a look at doing that. So we'll look at a couple of examples. So let's say we have a triangle. These are my axes. And they tell us, the problem tells us this is triangle ABC. Is isosceles. And they tell us that this coordinate is 0, 0. This coordinate is 2, 3. And this coordinate is question mark, question mark. And we want to find the missing coordinate. So for this kind of problem, what we're asking ourselves, or what the problem is asking us, is how far over, or how far left or right. So I say how far over. That's going to tell us the x part, and how far up or down. That's going to tell us the y. Well, let's do the easy one first. I'm going to put C over here, C, and we'll put in the coordinates in the parentheses. Well, if C is on the x-axis, how far up or down is it? 0. X-axis means we're 0 up or down. So this has to be 0. We're not going up or down at all if we're on the x-axis. Now I'm going to draw in this perpendicular segment here. And this triangle is isosceles. How far is it from A to this point? 2. That's what this tells us. If it's isosceles, we know that this perpendicular segment cuts the base in half. So this distance also has to be 2. So what is the total distance over? 4. So that means we're going over 4. So the coordinate of C has to be 4, 0. All right, questions there? Okay, let's make it one step more interesting. So for this one, we're going to look at a rectangle. I'm going to put my vertices here. So I'm going to say ABCD is a rectangle. So let me draw in my sides there. Make those lines a little thicker. So there's ABCD. And we know that A is at 0, 0. B is at 0, P, some number P. C is at question mark, question mark. And D is at Q, 0. So again, what this is asking us is how far over. That gives us our x, and how far up, or down. That gives us our y. Well, if this is a rectangle, how far over have we gone to get to there? Q, right? That's what that tells us. Well, if this is a rectangle, isn't this perpendicular? Don't we go straight up to get here? So how far over are we going to get here? Q. That also has to be Q. So the x part of C is Q. So this is Q. And how far up have we gone to get there? P. That's what this tells us. We've gone up P. So there's a P. That has to be P. So the coordinate of C is QP. And unless we knew what P was and what Q was, we wouldn't be able to write numbers in it. We just write it as QP. All right, questions? Okay, let's make it one step more interesting. Let's look at a parallelogram this time. So here are my axes. And we're going to say D is at 0, 0. We'll put E at CB. We'll put F here at question mark, question mark. And we'll put, let me draw in these sides. Oops, that's not what I wanted. I wanted this. I just want my drawing, make sure my drawing looks like a parallelogram. There we go. And we'll call this G. And it is at A0. And we want, so we're going to say DEFG is a parallelogram. And we want to find the missing coordinate. Again, we're saying how far up, how far over, how far up or down? Yeah.
Is G00?
A0.
Oh.
That's an A. All right, so let's do the easy one first. If this is a parallelogram, based on what they tell us there, how far up have we gone to get there? B, right? The second one tells us about up. So this tells us we've gone up by B. So that has to be B. So that's the easy one in this case. All right. The next one takes a little more work. So let me draw this in. How far over have we gone to get there? This is straight down there, so we've gone C units over. In order to get to this point, for this to be a parallelogram, doesn't that also have to be C? Yeah, it has to be the same distance over. See, well, how far over have we gone to get here? A. And this is, we decided was C. So if we've gone A here and C here, how much have we gone total? If this is 10 and this is 5, how far have we gone? 15 if this was 20 and this was 2. 22, so what are we doing to those? Adding, we need A plus C. So the total is A plus C. So the total distance we've gone over is A plus C. So the coordinates of F would be A plus C, comma B. So this question, something like this, that's similar to what you might see on the test. Nothing trickier than that. All right, questions there? Okay, all of the homework problems have to do with things kind of like the examples that we just did. So I'll write the homework up. We'll answer questions about homework, answer a couple of questions on simplifying radicals, because we did several of them in class the other day. Then we'll have I have a whiteboard activity that we're going to work on, and then we'll work on our quiz correction work. All right, there's that.